Okay, guys, in this platform, we are going to be looking into precision measurement. We just want to check how we have been talking, what exactly have been talking from our past exam papers. We've been working this, but do you actually understand where this is being taken from? That is the major part of these introductions. So in this case, we shall be measuring tapers using precision rollers. That is the major part of this class. So the introduction that we just gonna is just the basic part. When we are given a setup like this one, all right, we can actually use it to measure any part that we want. So in this case, we can calculate what is referred to as the included angle to calculate the included angle. So you can just say the included angle in this case is referred to as what? As I for the included angle. So provided that we have got the larger diameter that is given as D and the smaller diameter, which is this D, and using this height from this part of our triangle here, using the height that is the difference between these two heights. There's a bigger height, this one, and there's a height that is the final height. We have got the height that we are starting with, then there's a final height. So we're going to find the difference, that is the h minus h. So as you can see, guys, we are on a right angle triangle. So on a right angle triangle, we can use the properties of a right angle triangle to find whatever that we want from this part. So with this diameter and this smaller diameter that we have, and this height, we can find the angle A and use it to calculate what is referred to as the included angle, where the included angle is twice angle A. That is 2 times the angle A. So this is the formula that you're going to need in this case to get or to calculate the included angle. First, you have to calculate angle A using the formula. So this is the formula that you're going to use. The tan of A is equal to, so remember D is representing the larger diameter, then this small letter D is for the smaller diameter, the one on the bottom. H is the final, the initial height, and this smaller h is for the final height, as we saw this from our diagram, the D, the larger diameter, the smaller diameter, and so forth. All right, so this is the idea of our calculation of the included angle. So if we check here, we are given an arrangement for checking the included angle. So the question was the included angle tapered plug gauge in this case. All right. For a tapered plug gauge shown in Fig 4.2, calculate the included angle, which they are referring to as I in this case. Given that the working drawing years 18 degrees, 30 minutes. So this is the angle that we are given. That is 18 degrees plus or minus the what? Plus or minus 30 minutes as the included angle. So find out if the taper is within the limits of the gauge's range. All right, you are supposed to calculate the included angle, and you're supposed to test with this one that you're given, which is from our working drawing, and see if it is within the interval, within the range. Is it within the limits? So we said we can calculate, actually we can calculate this included angle, as we can see, guys, from our diagram here. We're gonna just take our data. That is, we have got the bigger diameter on top. We've got a diameter of 82. That represents the diameter of 82.68 millimeters. The smaller one, given as 66.24 millimeters. And in this case, this is the bigger height that we have. We do not have any distance, like we do not have the distance below here. So we just have the initial height of 50 millimeters, and the final height in this case, we do not have it. There's no movement. There's no shift. There's nothing. It was just starting from the ground. So you use that as a 0. So that means we can be able to calculate our included angle and test if it lies within the interval that we are given there. From our formula, we saw that the tan of A, which is the half angle, this one, it represents the half angle from our mathematics N4. If you're given 2A, A is the half angle. All right. If you're given A, then the half angle of A is half of A. So remember that we say the included angle is twice of this. So this represents what? Your half angle. So this is D minus D into H minus H. Remember our formula. That's what we have there. So we can calculate the A, that is the tan of A is equal to 0.5 into D, that is the diameter of 82.68 millimeters minus the smaller one, that is 66.24, everything over H, which is 50 minus 0. As we can see, guys, we have just a single height starting from the ground. So this is the tan of A, which is going to give us this as a single fraction, or you can have it as a decimal, depending with what or how you want to present your calculations. All right, let me just present this on a calculator. Let's just hope we're going to win here. So that is on our calculator, going to have 0.5 like this into the bracket. Let's have a fraction 82. All right, this is 82.68 minus 66.24, that's 66.24. Then we're gonna divide this by 50 minus 0. So 50 minus 0, there's no effect, it's just a 50 there. All right, so this was gonna give us something like this, which is 411 or 0.61644, something like that. So to have the value of A is gonna be arctan of this answer that you're just having there on your calculator, which is this arctan of the decimal 0.644. But use your calculator, just arctan as it is on your calculator. Arctan, the answer that you had, that's we have the angle now. So that will be 9.3, something like that. All right. So let me just fix this to 3 decimal places. Fix here, it's gonna be 3. So that will be 9.336. All right, so that's our A is 9.336 degrees. So from the angle of A that we have obtained, we are now going to determine the included angle. So the included angle is going to be twice now. So that is, we are told that let us just use I, as we are told I is representing what? The included angle. So that is 2 times 9.336 degrees. So that is going to give us, let us just have our calculator. But now if we are to check there, all right, let us have this value first, times 2. This is going to give us 18.672. 18.672 degrees. All right, but if you are to check here, we are going to see that this angle that we are given as our included angle from the diagram is given in degrees and minutes. So you are supposed to have your answer in also degrees and minutes so that at least you'll be able to compare, because you're supposed to compare to check if it lies within the limits. So how do you do that? Just press this. This is degrees, minutes, seconds on this button here. So if you press this, if you press this button, you're going to have degrees, minutes, seconds. So the degrees is 18, the minutes it's 40. So this is equivalent to 18 degrees, 40 minutes. So as we can see there, we've got 18 seconds. 18 seconds is less than 30. It cannot change even this one. So just leave it like that. 18 degrees what? 18 degrees, 40 minutes. Now, with this angle, let us compare, because we are supposed to check if it lies in within the limits, if the included angle on our diagram is 18 degrees plus or minus 30 minutes. All right, so from the given diagram angle, from the diagram angle, this is what we are going to see from our diagram angle. Remember, it was 18 degrees plus or minus 30 minutes. So we are going to have the lower limit. That is where our answer is supposed to lie. If we subtract, all right, if you add, that's the upper. So you can even start with the upper limit. You add the upper limit, that's when you are adding. So that will be 18 degrees plus 30 minutes. Guys, if you add 30 minutes to 18 degrees, there's nothing. So it's just going to remain as 18 degrees, what? 30 minutes. All right. But now we get to this one. The lower limit is going to be 18 degrees minus 30 minutes. All right. Remember that a degree is equal to 60 minutes. So the moment that we subtract is just like we've got 18 degrees 0 minutes like this, minus 30 minutes. So that means in order for you to be able to subtract, you're going to borrow here a minute. You're going to take a minute, a degree, actually, so that it gets here. So that will be 17 degrees. If you give that degree, it is equivalent to how many minutes? To 60 minutes. So you just subtract 60 minus 30, that will be 30 minutes, 17 degrees. So this is 17 degrees, 30 minutes. So comparing this, let us check now. We want to compare what we have. This, our calculated value is 18 degrees, 40 minutes. The minimum value is supposed to be 1730. The maximum 1830. This one is 1840, so it's out of the bound, out of the limit. So this included angle is out of the interval. All right, it is not within the interval. So 18 degrees, 40 minutes is not within the interval. Within the interval. This one is not within the interval. So if you're given this type of a question, that is how you're supposed to compare it. You calculate the included angle from that formula that I talked about, then you compare. But in typical exam questions, you see that in different cases that they'll ask something like this. Yes, they can do, but very, very rare. Let us check this one. This one, they do ask this, and you are supposed to be very, very careful. There we are given, in this case, we just need to extend this further. Fig 1 below shows a taper of 1 in 15. So there we are given a 1 in 5 on the top. So take note, on the diameter that must be tested for correctness by using 18 millimeters diameter rollers. All right, so these rollers that we have, they are of diameter 18 millimeters, and they are identical. All right, so meaning we've got 18, everything. That is our diameter in this case. So that means we've got a radius of 18 divided by 2, which is 9 millimeters. Since our diameter is what? It's 18 millimeters. So that's your diameter there. All right. Then what else? We are given the center distance between the top and bottom rollers is 55 millimeters. So as we can see, the center distance connected from our centers here was 55 millimeters. All right. Then we have got the height of 80 millimeters. All right. The taper is 8 millimeters long. That is the height. And the top diameter of the taper is 50 millimeters. So at the top part here, we have got a diameter of 50 millimeters. This is what we have. So calculate from a neat construction of drawings the distance across the top and the bottom rollers. So as you can see, there's a distance across on top here. Then also there's a distance below here. All right. So there, guys, you just have to be very, very, very careful how you calculate this. Your information is very, very important. All right, so I'm just going to try to explain this so that you'll be able to understand me here. All right, we want to calculate this distance X on the bottom and the distance Y at the top of the rollers. So if you consider the distance at the bottom is starting from the end of this roller to the end of this roller, it means the diameter is included, and also this bottom diameter is also involved. The bottom diameter is not X. This one is the bottom, this one. That's our bottom diameter. Remember, we've got the top diameter that we're given of 50 here. So the bottom diameter is going to be involved. The same thing if we check on the top here, the Y that we are supposed to calculate here, this Y here, it consists of from this point up to this point. So it means we are considering this distance and also the part of the diameter and this distance. So we have this distance, and the 50. So how can we obtain these distances? Like what I said for this one and the bottom, let us start with the bottom one. All right, we have got the diameter, we talked about this. Let us start with the bottom one. It involves this part up to this part. So it means we are involving the diameter from this point to this point, which is our lower diameter from the bottom. There's a diameter there. So we need this diameter first. Let us talk about that diameter. All right, but this diameter, you see that it is going to be linked with the calculation of this. Let me just show you before we move on. This one, let me just take it straight. Sorry for these centimeters that are showing. I don't want to show these centimeters, but it's just showing. No problem. Let me put it up to here. Okay, just remove. Okay, sorry for that, guys. Sorry for this. Let me take another one from this point. I'm going to take it up. Why is it not there? Oh, it disappeared. It disappeared. I don't want these centimeters that are showing here, but no problem. Let me put it this way. Okay, this is what we have here. So I want you to see that since we have got this distance that is from this point, I'm just going to name my points here. Let me call this A. Guys, just be with me. I want to explain something very small, then you'll be with me. Let us call this point A. Are you going to be able to see? This one is too light. All right, let me take this one. So this is our point A. All right, let us say this is A, and let us say this is B, and let us say this is our C. So as you can see, straight here, it's a vertical line, and this is a horizontal line. These two, they meet at 90 degrees. So the special thing about that is that this angle that you see inside here is your half angle of that. Remember, we said the included angle is equal to 2A. So this is your A, the half angle. So you can even just call it alpha or A, whatever that you want. This one. It is our half angle, this one. Alpha, which is the same as this one also, it's alpha. Being taken at 90 degrees. So you will see that in order for us to have this diameter, this one, this is our diameter, this one, all right? This one on the bottom, this one. You need to subtract this distance, BC. I'm going to present it so that you don't have confusion. Let me also have another BC. From the 90 degrees, this is my B, to up to this point, just like this BC. Also, this is my C. So you see that this distance between B to B, this one, is the same as this distance, which is our diameter, this one. So it means in order for us to have this distance, we need to calculate from B to C, from B to C, then we subtract it from what? From 50. We are going to subtract it from 50 there. But still, where are we going to have BC? BC is inside of a right-angled triangle, this one. Where I said inside of this right-angled triangle, there is an angle alpha there. So where do we get this angle alpha? All right. The angle alpha, we are going to take it from this way, guys. They gave us a taper here that it is of 1 in 5. So a taper of 1 in 5, it means you're going to take this part. You see, this is your taper, this one. Just going to present this way, like this. So it's just going to be like this. So you're given a 1 in 5. So it simply means if you take these points forming up our alpha, this one and this one, forming our A or our alpha, I'm just going to present it this way. So you'll see that we're going to have something of this nature at the end. Guys, if you combine, I want you to see, if you take this right angle triangle, this one, and this right angle triangle, this one, it's like this. It's like this. Yes, I know our diagrams, they present it somehow. It's fine the way they present. It's just one and the same thing. You understand me? It's like this. It's like this. This is what we have. If you combine this one and this one together, this is what we have. So you've got something of this nature like this. In between this one, we've got a distance here, which is joining these two. So this is at what? At 90 degrees. Sorry for that. So what it means at this point is that from our taper ratio, you can also draw it like this. Sorry, you can also draw it like this. It's one and the same. You can also present this way. So it simply means this one is our right angle triangle, which is this one, our right angle triangle. So these are the half angles, the alpha or the A, the way that you want, alpha and alpha. So this one, it means a taper of 1 in 5. It means every like for every intake, for every increase that we have of the diameter. If the diameter is increased by 1 unit, the taper length increases by 5. So you take it this way, this is going to be 1. And this will be 5 units. This will be 1 unit. So remember, you want to calculate alpha. So take it as an advantage to say if this is 1 unit and these two are equal, so it means this is symmetrical. So if it is symmetrical, it divides this into 2 equal parts. 1 divided by 2, that will be a half, which is 0.5. So this is simply 0.5. This is simply 0.5. So it's the same thing. This is simply 0.5. This is simply 0.5. This is 5. So you want to calculate alpha. You can calculate this according to this. This is opposite. This is your adjacent. So from our ratios, SOHCAHTOA, from our mathematics there, from our SOHCAHTOA concept, which ratio uses the opposite and the adjacent at the same time? So here we want to calculate what? The included angle. This whole part is to calculate the included angle. We need this. Calculate. In actual sense, we don't need the included. We just need the half angle. Yes, the whole of part is going to be the included angle. All right. But we need the half angle there. So calculate the included angle. So the included angle is twice alpha. So I is equal to 2 times alpha. All right. So this alpha, like I said, we've got opposite and adjacent, opposite over adjacent, which is the tan. So that means the tan of alpha is equal to what we have, the opposite over the adjacent, which is 5. So to find alpha is going to be arctan on the other hand. So it's arctan 0.5 over 5. Or if you divide, it's going to be 0.1. So that is arctan, just like I said, guys, from your calculator, it's going to be 5.711 degrees. So if this is our alpha, this is the best, this is the one that we need from our diagram. Yes, this included angle, you can just talk about it, 2 times 5.711 degrees. That is, we're going to get something like 11.422 degrees. It's not important, this one. So now for now, we need this one. If we need this, we're going to calculate it. But this is the one that we need, which is the half angle. Like I said, this is the double angle, which is your included angle. And this is your half angle. So with this half angle, if you take it here, because remember, the purpose is that we want to find what? We want to find BC. So the purpose of calculating this included angle, this one, that we said it's 5.711 degrees. It is the same as this one, also this side, 5.711 degrees. So with this, guys, we know this height, this one. We have this height. Let me remove this so that we can properly see what we are working with. This is the height, this one. From this point at the end up to the end point, the height is what? It's 80. So meaning to say the whole of this line is what? It's 80 millimeters. All right, sorry for that. So this is 80 millimeters. So with this information, guys, can't you see that? We can calculate this. This is the same thing, 80 millimeters this side. So you just work with one triangle, this one. So let us calculate what? Our diameter. Like I said, in order for us to calculate X, we are going to need the diameter on the what? On the bottom part, all right? Which is the diameter on the base. So guys, allow me to remove this part since we have used it and seen where it has played its role. So we are going to calculate. So to calculate X, all right, you need, all right, this is what you need. So to calculate X, as we saw that we are going to need the diameter. You need the diameter on the bottom. The diameter on the bottom. All right, we have got the top diameter, then we've got the one on the bottom. All right, and also we're going to talk about these distances here, this and that later on. So we need this first. So calculate the diameter. So calculate the diameter. Calculate the diameter at the bottom. At the bottom. All right, so this is the procedure. In order for us to calculate the diameter at the bottom, I'm going to take triangle ABC. So from triangle ABC, you will see that it's a right angle triangle like this. Triangle ABC. So this is my triangle ABC. It's a right angle triangle. This is 5,711 degrees. Remember our half angle. And we said AB is the same as this height, 80 millimeters. So we've got 80 millimeters. We want to calculate BC because BC is part of, you see, guys, something that you want to calculate is part of, as long as you know those steps, you are done with this. You're done. So how do we calculate BC? Where do we need BC? We need it here to the diameter. All right, so according to this angle, this is opposite. This is the adjacent. So the tan of theta, as we saw, guys, opposite and adjacent is from tan. So that means, all right, let me just have this removed here. Just need this space. Let's hope you understand me, guys. So we say the tan of theta, the tan of 5,711 degrees is equal to the opposite BC over 80 millimeters. So just going to cross multiply. BC is equal to 80 times tan 5,711 degrees. So with your calculator in degrees, you are going to calculate BC. And that was going to give us 8,000, something like that. 8,0, which is just approximately 8 millimeters. Okay, with our BC, let us calculate now the diameter, because we said we need this diameter at the bottom, and we said it involves of BC. So the diameter, it's a combination of what? From 50 millimeters from the top diameter. So from the top diameter, I'm just going to call it D. And this one, I'm just going to call it small letter d. So from D, the top diameter, this top diameter D is equal to AB, this one, I mean the BC, this one, and the BC. So it's just 2BC plus the diameter on the bottom, which is this one that we want, which is the same from here to here. It is same as from here to here. So if you take the whole of this line, which is the diameter on the top, it's a combination of what? Of BC, BC, and the diameter, which is the diameter on the bottom. This one is the same as the diameter on the bottom. So that means we can calculate this. So it's D minus 2BC is equal to the diameter on the what? On the bottom. So we are going to have the diameter on the bottom. That is the diameter on the top. 50 millimeters minus 2 times BC, which is 8. So that was going to give us the small diameter of 34 millimeters. So there we have got 34 millimeters. All right. We are still there. We haven't started. Remember, we want to calculate X. We want to calculate X. But what is the purpose of finding this or having this smaller diameter here? What is the purpose? All right. I'm just going to take my point A. All right. Remember, we have got A there. So now we have got this diameter on the bottom here, which is 34 millimeters. Okay. Now you understand me. Now you're going to understand me. Let's move on to this one. We want to find this distance here. This distance here. This is what we want here. So we want to find this distance X here, this one. This is the one that we want. So it is comprised of what? All right, if we move here, X is comprised of the smaller diameter on the bottom here, this one on the bottom. Take note there. All right. It is also comprised of this one. Let me just name these points. I can even name A, B, or whatever part that you can understand. Let me continue with the A. So this one, from A to this point, okay, let me take it this way, from A to this point, to the center. I want to take it from the center to the center like this, which is the same as what we have on this side. This is same as our A here. So we are moving from A to the center like this, to the center. So if we take it back to the radius, guys, let us go back to our mathematics. We know that a circle like this from our mathematics, a circle like this, when it meets a line like this, it's a tangent. It's not inside, it meets also this one, it's a tangent. And we understand from our geometry, from our mathematics, that two tangents, when they are connected from the external points of a circle like this, they are equal in length. So these two tangents, they are equal in length. And if a line is drawn from this to the center, it bisects this angle. It bisects that angle. So we have got a lot of geometry there. All right. So let us consider our geometry part. We said this one is going to be divided into two equal parts. This angle, all right, is going to be divided. Let me extend it like this, but it passes through the center. Remember, here from the center to this point is the radius, and a radius and a tangent, they are perpendicular. They meet at what? At 90 degrees. So let us call this point, this one, remember, it is our A. We used this as our A before. So I used A, I used B, I used C. All right, let me take C and I used C. Yes, so let me take D and E. So let me just call this point D at the center. So D is the center and E is the point of tangents. It is the point of tangents where the tangent and the radius meet, and they meet at 90 degrees. So this is our radius. This one, it's our radius. DE is the radius. So R is equal to DE. DE is the radius. And remember that we said our radius is what? 9 millimeters. So guys, I'm not going to repeat what I'm doing. What I'm doing this side is identical to what is this side. So it means if I'm calculating AE, I'm also calculating AE up to this point here. I'm gonna call this AE. Okay, but let us move because this distance is covering up to the end of the rollers there. So from this point E up to the end, what is it that we have? From this point up to the end here, what is it that we have? This one. There is a radius here, this one. It's a radius. It corresponds to the radius. So the last part here from the point E, this one. This is our point E. Direct here, this is our point E. Up to this point here, this one, it's equivalent to the radius. Check properly there. That is your radius. So it means also here, we also have what? A radius at the end there. So if we take this, guys, we can calculate X. So in this case, let us calculate X. All right, so if we take this into consideration, we can be able to calculate what? To calculate the distance X. So to calculate the distance X, we are going to see that X is it's a combination of these, all right? X is a combination of a lot of things here. One, it is a combination of this diameter of 34, but it's a combination of this radius, all right? This radius again, or let me just write them one so that I combine them so that I don't lose you guys. I don't want to lose you. So this is radius plus EA, which is AE. This one, we said AE and this AE are the same. So we've got radius plus AE. Then we move on from this. This is the diameter on the bottom plus another AE, which is the same as this AE that we had, plus another radius, which is the same as this radius. So if you take into consideration our X is equal to radius plus radius, which is 2R. And we have the radius. AE and AE, they are the same, so it's going to be plus 2AE. So as long I calculate this AE, I'm done. So where do we have, or how are you going to find AE? Remember, we are given that our diameter here is what? It's 18, which is, we said radius, it's 9 millimeters. All right. And I said from our geometry concept, this angle is going to be divided because this one is also a tangent here from this line. We are also having a tangent here. So there are two tangents like this. From the external point of a circle, two tangents, when they are drawn, they are equal in length. But if you join them to the center like this, they bisect. This angle is bisected into two equal parts. But before we agreed, or we can agree that the angle at A, it's 90 degrees, this one. From this top here, going up, down to this point, going up, going down like this. the angle, this one, it's 90 degrees. Why? Yes, we know that these two angles are equal, but this one is 90 degrees, the whole of it. Why? We are talking about a horizontal and a vertical line. So this whole angle is what? It's 90 degrees. So to find the angle that we are going to need inside of our diagram here, inside of this triangle, because remember, we want to calculate what? We want to calculate AE. So we are going to use the triangle from triangle AED. So from this triangle AED like this, you're going to have something of this nature. This is your point A, this is your E, this is your D. So remember, your DE is the radius. So we've got 9 millimeters there. So I'm worried about the angle, this one. So this angle here is the same as this one. This is the one here, this angle and this angle. But there's an angle, if you check here, there's an angle inside our half angle. That one, the alpha that we calculated before. So 90 degrees minus alpha, which is 90 degrees minus this 5,711 degrees. We obtain the whole of this angle that is remaining, the one which is, we said, is this one here, which is combining these two angles. But since these two angles are equal, how do we find one of these ones? We divide by 2. So theta is going to be 90 degrees minus this one over 2, which is theta is going to be something like 42,145 degrees. 145 degrees. The theta that I'm talking about is the angle inside of the triangle here. I'm going to call this theta. 42,145 degrees. I hope we are together on finding this theta. All right, I hope here we are together on finding this one. We are saying this is from our geometry part, all right? This is a tangent, so it divides. So these angles, they are equal. But the whole of this angle there, it's a 90 degrees that we are seeing here. So from the 90 degrees concept, we are saying this 90 degrees minus the included angle, this one, we get the angle that is remaining, which is the sum of these two, all right? Let us do it this way, which is the sum of these two. So as we removed this one, the included, this one was our included angle, this one, 5,711 degrees. So if you subtract, you remain with the whole of this angle, the whole of this, but it must be divided by 2 because we are joining to the center. That is why we divide by 2. All right. Now that we have got this theta, what's the purpose of finding theta? It is because we want to calculate, remember, it was AE. It was ADE. This is AE. We want to calculate AE. So to calculate AE, we can see this is our adjacent from a right angle triangle. This is opposite. So we can use our trigonometrical ratios. Again, we can go back to our trigonometrical ratios where we have opposite and adjacent, that is tan. Again, the ratio of tan. The tan of theta, which is 42,145 degrees, is equal to the opposite, which is 9, our radius, this one, over the what? Over the AE. So this is over AE. So by doing this, we can calculate AE. That's it. We can calculate our AE here. Just cross multiply, then we divide. So it's AE times the tan of 42,145 degrees is equal to 1 times 9, which is 9. Then we can divide by this, both sides. So let us just divide. So therefore, AE is going to be equal to 9 over the tan of 42,145 degrees. So this is 42,145 degrees. Okay, so that's it, guys. We can have the distance or the length of AE. Okay, so thus we can find the length of AE from these calculations. And that was going to give us 9,945 millimeters. All right. Now that we have got AE, we can find X, because remember we said what is just missing there is AE. So our X, like I said from our formula, is 2 times the radius. We have, or we know the radius there. We said our radius is what? 9 millimeters plus 2 times AE. AE is the one that we are calculating here because we said there are 2 of them, 9,945. Just to hope you Still remember where I explained the 2AE concept, that they are the same. Once you calculate from this side, you are also calculating on this side. So just calculate once, then you multiply by what? You multiply by 2. So that's the idea there. That's the whole idea. So that was going to give us X, which is the bottom distance. And that was going to be 71.89 millimeters. All right, the other thing that the major reason why I'm bringing also this, if you check, I saw that there's a lot of errors that we had from our textbooks there, especially on calculating the Y value. Let us be careful there. All right, let us just take what is important, what we're going to need. We're going to need this X. All right, we have this X. Let us just put it here and see how we're going to calculate Y. All right, I just hope, guys, you'll be with me. Just hope you'll be with me. Let me just remove this part. And so we calculated X. We now know our X. Remember, this was 14 millimeters, the diameter first. Then we calculated this X, the whole of this X, we got it. Our X is equal to, we got 71.89 millimeters. All right, up to this point. So the last part is to calculate Y, all right, which is the top, this one. Remember, we want X and Y. We want to calculate the value of X and the value of Y. All right, let me just remove some unnecessary information that we now have here, guys. This is now not necessary. All right, let us see, guys. We are almost there. Here, let us check. Guys, know your diagram. All right, I want you to see this part that is happening here, because this one, it was a little bit complicated, but not that complicated, just a little bit. If we consider what is happening here, all right, the Y is consisting of this. All right, let me take this one first. This wall of Y here, it consists of the 50. So if you take this 50, this one, if you take from here up to here, we have taken this whole 50, this one. If you taken this, it means you just have to calculate this, the remaining distance, this one. You just have to calculate this one. That is what you need. But this distance, guys, if you take into consideration, it is a combination of two things. There is a radius from here to here. There's a radius to be considered. All right, let me put those lines. There's a radius to be considered. If you take here from the center, going up like this. All right, let us just leave it here. All right, then we do the same thing from here to top. Is the same, like what we saw on that same, on the other hand. It's just one and the same thing. Sorry for this. So if you check here, this is the radius from this point. I'm considering the whole of this. So from here to here, this one is here to here, which represents what? The radius. This is the same thing from here to here. We've got a radius. From the center to this point, we've got a radius, which is the same as from this point straight here. From this point up to this point, there is a radius there. All right. So if we take this, you'll see that, okay, let me remove this. That was our point C. We know that this is our point C here. You see that the distance that we want here in between, it is a combination of the radius. But the radius, since we know about this radius, let us leave this one and this one. Let us not talk about it. Let us not touch that part. Let us just leave it like that. Okay, let us go to the second part again. If we take it the same way from the end point here going up, let us take it the end point going up. I hope you understand me, guys. I just pray that you do so. If we take from the end part going up, these centimeters are the ones that are disturbing me now. Okay, so if you take it from the end point going up like this, you have taken this one going up, this one going up. It's identical. What you see here is what you see there. Guys, you see that the distance that we need, this one here, it is a combination or it is a part of a radius, not the whole of it. No. It is a part of the radius, because from here to here, let us present again. From here to here, the end to the circle, what we have, it's a radius. All right, from the end point here to this point, it's a radius, which is the same as this distance up to this point. It's a radius again. So it means if I have the radius, what I need there, which is the most important thing for us, is this smaller distance. Let me increase it a little bit. This one. Let me increase, let me remove this C, this one. What we want there, because what we need is the wall, is this one, this one, this is one, this one, which I said is the radius. And it consists of this distance. Are you seeing this one from here to here? Here. Where can we have this distance? This one. If we can have this distance, therefore we just subtract from what? From the radius. So let us put this way. I'm gonna so that I don't put confusion in you guys. Let me say from here to here, this smaller distance, this one, let us just call it, which letter did I use? I don't want to change the letters that I used here. All right, I can just use X. All right, we can just even use smaller letter X like this. Smaller letter X like this. All right, then from here to here, I'm gonna use smaller letter Y. Here, I'm gonna use smaller letter Y. So the both of this smaller letter X, this one, if we combine this, you get what? The radius. It is equal to the radius. But as we want this remaining part, this Y, this one, because it's not part of this 50. 50, it ends here. So the X, it's part of 50 already. It's inside of 50. So Y is the one that we do not have. So we need this Y. But this radius is equal because we said it's a combination of two things, the radius and what? And Y. As we need Y, so Y is equal to radius minus X. So you have to find X. You have to find X. You have the radius. So it is the same thing also this side. It is the same thing also this side. This is our X here, all right? This is our Y here. From this point to this point, this is our Y. So we need this Y here. The X is already part of what? It's already part of the 50. The 50 is already covering this one, the D. It is already, take note where 50 is coming from, this one. It's coming from here up to here like this. This is your 50. So 50, it already covers X. X is already inside of the 50, this X. It's already there. So when you are calculating Y, you don't involve X. That's why we are subtracting that X here. So it follows that to have the distance to find Y, finding Y. To find Y, in this case, Y is going to be equal to, we're going to take the radius. Take note where it is starting at the end there. It is ending at the end. So we are going to start with the radius. So it's going to be R plus what? Y, this one is involved. I'm just going to call it Y. X is not involved because it's part of the 50. If you take this 50, the whole of it, you are not considering X. X is already taken. So you're going to add 50, not X. No, X is already inside of the 50. So you move, you have already taken this whole line up to the end. We are now here. So where are we going to continue? We are going to continue from Y there. So we are going to add Y and the last part, which is what? Which is the radius. So this is the formula to find Y, which is the topper, the distance that we have. So this is R plus R, radius plus radius is going to be 2R. Y plus Y is going to be 2Y, then plus 50. So with these guys, we are going to calculate the value of Y at the top. So the question is, because we have the radius, we know that the radius, guys, we are given that the diameter there is 18. So radius is what? 9 millimeters. We have the radius, but what about y? So let us talk about y now. To calculate y, we said to calculate y, it's radius minus x. So it means the part where x is going to play a role is when we are calculating this distance for x. All right, let us complete this triangle, this one. From x, if we go down to this point, we are going down to this point like this. All right, this one. You will see that this one, we have the distance because, all right, let me not rush. I just want I just want you to understand this. This one, we already given the distance. Why? If you are to take into consideration here, we are given the distance here, the center distance of 55 millimeters, this one. The center distance, this one. And we are given the 80 millimeters, this one. We have got what? The 80 millimeters, the whole of this distance. So it means if we are to subtract this, what are we going to have at the end? 80 minus 55 is going to be 25. 80 minus 55 is going to be 25 millimeters. All right, guys. There's another thing that we do not consider here on our subtraction. Take note, guys. This is also the part of 80 starting from the ground up to this point. So it means once we subtract this one, the 55, we are left with also the radius here from this point up to the ground. From this point up to the ground there is a radius, and our radius is 9 millimeters. So in order for us to have this point that we are going to use on our triangle, we have also to subtract the radius there. So we have got this part of our triangle. Remember our right angle triangle, I said we're going to just have something like this. What is on this side is same also on this side. So this angle, from our geometry, you will see that this angle, if this is the angle we said that was 5,711, this is also going to be 5,711. Sorry for this, guys. So this is our angle, 5,711 degrees. All right, then this is the x, this one. This angle, they're the same from our corresponding angles, or you can use vertically opposite angle. This angle and this angle are equal. This angle and this angle are equal from the alternate angles. Then these ones are vertically opposite angles, or we can just use corresponding angles straightforward because these lines, they are parallel. All right, so this here is the distance that I'm saying, this one. Yes, we know this is our x, but this distance, this one, is this one that is remaining here on top, this one on top. So if you're to consider that, we have to also remove the radius. So 80 minus 55, but also the 9 has to be subtracted because there is a distance to be covered before you reach before you move on to this point. Because this one, yes, is starting at this point, which is fine, the 55, but it's not considered, it's not covering the radius, guys. The radius is not being covered there. So it's a mistake that we can have at the end like this one. So this was going to give us 16 millimeters. So with the 16 millimeters here, this was going to be 16 millimeters on this one. We've got a right angle triangle, so you can calculate x opposite adjacent. So it's the tan of 5,711 degrees is equal to the opposite x over the adjacent 16. So we can cross multiply. X is equal to 16. So this is 16 tan 5,711 degrees. So that's our x. All right, so 16 times the tan of 5,711, it was going to give us 1,6001, which is just 1,6 there. So with these guys, we can be able to find y here because we said y is radius minus x. So that means y is going to be radius. Remember, our radius is 9 minus x, which is 1,6. So y is going to be the difference of 9 and 1,6, which is 7,4. That's 7,4. So having this, we can be able to find the y. This one is the y, or the one that we want. This one is just, you can use letter G, you can use M, you can use N, you can use X, whatever that you want there. So this is 2 times the radius. Remember our radius is 9, plus the y that we have been calculating here is 2 times 7,4. All right, 2 times 7,4 plus 50. All right, so if you multiply this, that is going to be something like 7.4 there, which is 82, something like that. So it's going to be 82,8 millimeters. All right, so that is going to be 82,8 millimeters in that manner. So guys, we have more questions to work on, more revisions to work on. Let us just try to revise and do more recap and revisions for more to come till we meet again.